Hello all. So let me first of all correct the chats. Okay, so I have turned on the chat. Now you can comment whenever you like. Okay, so in this video, in this live stream, I'm going to cover how to operate a keypad using 8051. I am going to cover the most, um, what shall I call it? The basic form of how to control a keypad, and for that we have to look into the details from the book, and we have to make use of the old program, the UART program. um, what we'll do here is once we press a single button on the keypad, we'll get to like get to see the pressed button on the um, UART panel. So let's go to the keypad, uh, chapter number 333. Here we go, and let me open it up. Let's go with the C version. Here you can see the keypad matrix, how it operates. So here is the the assembly language program, the simplest program which you can get. And here you can see the pseudocode, the flowchart of how to get a keypad operational, how to make it operational. And what is it doing over here? And send the result. Okay, yeah, here it is doing the same thing as I want to do. What it's doing is it's once a key is pressed on the keypad, it will show the same thing on the UART board. So this thing is what I want to achieve. I'm going to take help from the previous program that I wrote, and hopefully let's get started with it, and let's see how it goes. So I'm going to keep this program as it is. Let's do the modifications right in this program. Okay. Well, I have attached the keypad to port 1. So let's take port 1 into account. How to get port 1? Let's define first. Define keypad and port 1. Yeah, there we go with the port 1, and let me see how to is Keil window operational? Yeah, it is. We can see it now. Okay. Well, for this we have to make use of the. Okay. Yeah. Um. So what I'll do here is, first of all, let me just make use of the keypad, and let's write a simple program where I disable everything on the keypad, on the port 1, and let's see how it goes. It's on the same line. Where is the error? Oh, I've got an error over here. Now what's the error? What it says? Oh no, it's already defined. What's the error? Undefined? It is defined. Okay, maybe it should be defined over here. Let's see how it goes. Yeah, obviously everything should be defined on top. So that's the error in our case. Name is undefined. Oh yeah, this was the issue. This was the main issue. Okay, got it. So according to this logic, port 1 now should be, let me turn on this book. So port 1 now should be blue. Let's see. And oh, I haven't included the hex file yet. Let me include the hex file. It is a C file now, and let's see how it goes. Yeah, so now it's blue, and let's move the 1 throughout the keypad, sorry, port 1. So for this, what we'll have to do is, we'll have to take a little bit of concept from the book on how to operate. um, Let me see. I want to write the binary digits, so let's see how it goes. How to write binary numbers in Keil. I am searching it online. Okay, so I have looked it up online and there is no way that we can work this out. So we'll have to use either binary or sorry, either decimal or hex. There is no rule to define a binary number in our current compiler for this Keil. Um, so what I'm going to do is I am going to use a calculator to convert all the values. So at first, let me just do it for binary. Um, it is going to be 1000 and 0000. So it is going to be 80, 0x80, and we are going to introduce a bit of changes over here. So after this 0100 and 0000, yeah. So it is 40 now, 40, and I think it is 20. 20. One zero zero zero. It is 10. Here we go. Let me add a bit of delay. So with this delay, we'll be able to see everything that's happening. Hopefully, let's add a bunch of, a big delay. Let's see how it goes. Bismillahirrahmanirrahim. And hopefully it will work now. Yeah. So you can see one traveling all the way up, and then it will go through this 1.7 pin. Yeah. So now at least it's working. Let's now since we have to check for all the pins in the keypad, we'll have to. I've already written this program where it sequentially turns on and off one pin individually. So what I am going to do now is to within this program to just read the pins. So let's read a pin. To read a pin, I'll have to take the input from here keypad. I'll have to read it, and let's throw everything. Since we already have port 2 empty, I'll be throwing everything on port 2. I hope this is visible. No, it wasn't. It wasn't visible. Let me show it to you. So this is how it went. First pin, then the second pin, then the third pin, and it traveled all the way to pin number 1.4 and then all the way to pin number 1.7, and it will alternate between all these values. Yeah, here we go. So what I'll do here is I will read the values. I will read the values and then I'll throw the values to port number 2 equals to this exactly. So it will just give you an idea, a rough estimate of how things work. Let's run it, and you see port 1, port 2, and over here as well. Yeah, so let me stop this simulation for a while. Let's get back to the business. Now what I have to do is I'll have to just you know um, check for pins, check for a couple of pins, and let me just connect keypad over here. Let me install a keypad. It will help us a lot to, to visualize everything. So I think it's better now this way or this way. Well, it is going to be upside down. Let me mirror it on the x-axis. Now it's better. Okay, got it. Let me connect all the pins, all the necessary pins that needs to be connected throughout this circuit. And here it's now all the columns are connected. Now I'll have to connect all the rows just in this similar fashion, in this exactly same fashion. And here we go. So now as soon as I turn this on, you'll be seeing this the column section over here. It will be um, the red line, the red light on top of the pins. It will alternate between all of these pins. So once I press it, you'll see, you see. So once I press it, the pin goes 0. So what I'll do here is, I think it's better to just make all of the pins as yeah, it's better to make all of the pins 1, and then we should try to, we should try to scroll just a 0 throughout the pins. So it's not we should not make use of a 1, we should make use of a 0. Let's do it. 0 1, let me calculate it first. 0 1 1 1 and 1 1 1 1. It's 7f 7f. It is going to be a bit difficult initially, but obviously once we have the table, then it's going to be easier. Bf over here, Bf. And what about this one? 1 1 0 1 1 1 1 1. It is df, df. And what about this last one? 1 1 1. Oh, 1 1 1 0 1 1 1 1. It is ef in this case. Yeah. Now I got all of the values, and now let's program it again, and sorry, let's see how it goes. Here we go. Now what happens is, as soon as I click this line, you see the other line also turns off. So now this thing is helpful in our detection, and we'll make use of this thing. Let me just okay. um so as you can see, we have accomplished at least something, which I think now is the time where we try to read everything and try to execute um, the keypad program. So what I'm going to do is, I am going to take help from book just to copy this 4 by 4 array, because it defines the keypad, and I am going to copy this whole thing in my program. I am going to copy it right here on top of everything. So let me just control C it, and let me make use of This way now it's better to understand. Okay, great, 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 great. So, um, we need a bit of bit masking over here in this thing. Um, so, what happens if let me just turn on this simulation for a while, and what happens if we press this button and this is blue? Let's pause the simulation over here. Let's do it here. Yeah. What happens if I press this button right when the this pin is blue? What happens? This pin right here, it will turn blue. It will turn blue. So I have to detect if this pin turns blue. When this pin has turned blue, then obviously a zero button is pressed. So I have to read everything now. So what I'll do here is I'll now study the program. Okay. Now, if 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 uh, keypad and 0x, let's not do this. Keypad equals to 0x f7, because let's see what happens. Let's see what happens. um, let's not conclude everything for before we got started. Let me just do this, so we detect what's happening. Let me copy this thing as well, and let me place it right here. If this thing happens, then obviously just print a. If keypad is equal to this, sorry, when keypad is equal to this, and obviously it's not going to be f, it's going to be 7 7. When keypad is going to be 7 7, then just print this thing. So this is how it will work. And let me just add a bit of delay over here as well, because I don't want this thing to just crash out. And let me just burn this program and check it out if it works. Okay, let me turn on the simulation. Mm-hmm. Let's see how it goes. There is something. At least we got something. Let me see if yeah, the baud rate is fine. We got something at least. A question mark. Oh, I think we missed it. We got a question mark. It's better than having nothing. Uh, so we got something at least. I am happy with that. With these results. What I am going to do now is I am going to write this whole thing for every every keypad over here. Sorry, not this thing. Again, I want to write this for whole keypad like this. And don't worry, I'll replace the other stuff in a while. Okay, let me replace it, and it is going to be EE, it is going to be DD, this one is going to be BB, and I am going to change these things as well. A, B, C, and D. There we go. Let's see how it works. Uh, there is something. There is something. Nothing, nothing. We got nothing. Nothing, nothing. Just for the first one. Just for the first one, there was something. Nothing for this. And what about this? Oh. I haven't cleared the register. I haven't cleared the registers. I think I have to clear the register first. Okay, I have to wait for it to be transmitted. I wasn't waiting at all. That's probably the issue. I think now it should work. Okay. Let's keep it pressed. We got something, and we got something. Nope. In this case, nothing. In this case, nothing at all. And what about this? We got something. Okay, so first pin is working, and we clearly have no idea about the other pins. Let's see. Uh, what about? Okay, so only pin number first is working. So what we have to do is we have to clear up the things first of all. Okay, just this thing works. So if keypad is BF, then with a bit of delay. If the keypad is wait for it to be transmitted, and everything seems to be working fine, but there is some issue with the sbuff register, since this is not the same thing I sent. It's not the same thing that I sent. Okay, so we'll do one thing. I will do one thing. We'll take help from the book. We'll take help from the book, and what's written in this book is the same thing that we do. Let's compare it first. T mode is 20. TH1. T mode is 20. Where's T mode? TH1 is okay. Our baud rate is wrong. So that's the main reason. Baud rate is wrong. TH1 is -3. -3 and S1 is 50. Okay, it's -3. Let me correct it first. It's -3. Is it -3 or? Yeah, seems to be -3. Let's see. Let's see. I I have corrected the program now, and let's see how it goes. Still, still the same issue. Still the same issue. Nothing has changed. Literally no change there. Hmm. Let's see if I have missed something while erasing the program. Starting the timer and then everything seems to be working fine, but still I'm not receiving anything. T mode is 20 and DH1 is the same, it's 50 and 1. Everything is fine. Just let me copy this ms delay, the same function which there is a function in the book which I see. I think it's very good function. We can make use of it. These are the two functions. One is send tx. Send tx, essentially it only sends the value on the board, sorry, on the UART board. So we can obviously make use of it. Let's copy this thing. And I don't have any trust in my own function because I haven't calculated it. To be exact, I haven't calculated it to be be a milliseconds delay. I have just randomly written it and expect it to work for a millisecond. So let's copy the thing we have in the book. So now send tx should send uh, a character. Okay. So now what we'll do is we'll first of all, just to just to make sure the program is started, let's write something so at least we know that the program is started yet. Let's write h, and in the next line let's write I. So this way we know that our program is started, and over here we'll write new line character. So let's the issue what's the issue now? Delay. Oh yeah, we have changed the function. It's now ms delay. Let me change it to delay. Yeah, now it should work. Yeah, so it works now, and the hex file is already created. Let's see what happens. Why is it receiving some junk values in the UART terminal? Okay, no, the polarity should be none, and everything is fine, but still it's not receiving the data it's supposed to receive. Let me see if I have the frequency set to the same. Still, I am receiving some junk data. I don't know why. Why is it sending junk data? Let me just Control Z everything and see if the main program, the previous program which we had in the beginning, does it work or not? Let's have a look. Yeah, it works, but how idiotic is this? My current program is not working, although I have everything set up, but there has to be an issue. There has to be an issue. I'll figure this out. I'll figure this out on my own. Let's copy this thing. Let's copy this thing and let's run it before everything. Probably it will work fine in this case. Let's see. There are zero errors. Let's see how it goes. Let me. Yeah. So at least it got something. Yeah. Nothing over here. Nothing over here. Yeah. So after printing something, it gets stuck somewhere. I don't know why it's going on like this, but okay, I got it. I got it. I think the issue is that we are not sending proper data. Now it should work. Now I think it should work. Now I think it should work. Yeah. So we were not sending a byte, we were sending many bytes. So this comma, this indicates that we are sending many bytes. Okay, 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 got it, got it. Let's correct this thing up, and now we should receive ABCD when we press the pins. So first of all, wait for it to compile. Wait, 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 wait. Is it compiled? Yeah. So now it's compiled, and let me just go and see if I keep it pressed, what will happen. A, and with this a B. Oh, I missed it. So let's press this last one. Nothing got printed. How strange. Still it has issues. Oh man. Let's see. There's some issue with my laptop charging, so I think we might have to end the stream after a while. There is some issue with my charger, with my laptop charger. Not getting charged up. The battery is not getting charged up. Yeah, so I don't think I can continue this stream for a very long time because apparently my charger is not working, my laptop charger. Yeah, it's not working. It's definitely not working. So the main thing is, just let me see how much program I can write now. I can develop now. Let me write the whole program. Okay, let's copy the program from the book for now, because it will take a lot of time for me to write the program, and obviously I don't have the time. My laptop is running out of power. Oh, it received power. So there is definitely some issue with my laptop. Let's not get into the detail of everything. Let's just copy this program from here. I was trying to recreate the whole program, but I cannot do it right now. I cannot trust my own laptop. Um, so that is why I'm going to copy all of the program from the book, and I'll just explain it a bit, uh, about how this thing operates, the how this program works. I'll just give you a brief introduction. So yeah, everything is copied and it works well. Okay, let me arrange everything for you. Let me just close this book and let me arrange everything real quick. Here we go. I have arranged everything. Oh no. My laptop is not charging up, and this is a very big issue. I have to keep an eye on laptop charging as well. Okay, I'll try to explain this as soon as possible, because I have no idea how much charge I have left in my laptop so far. Okay, I think I'm done over here. Yeah. So, yeah. So what's happening over here is, it's the same thing. Essentially, it's exactly the same thing. But what happens is that the columns of the keypad are connected to port 2, and the rows are connected to port 1. um, so what we can do is we can try to connect everything to port 1. Let's see how it goes. um, let me just do this, and 0x f0. Let's see how it goes. Bismillahirrahmanirrahim. Oh, target not created. There is some issue definitely. Let's see if this compiles well. 28. Okay. All. Mm-hmm. It's not working. It's not working as it is supposed to work. Let's make it. Let's make it int, and I think it will work now. Oh, 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 oh. We can do one thing. We can. I think we have to do this. We have to do this. It will shift the bits 4 times. So let's see if it works well. No, 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 no. Still got issues. Still got issues. Let's do it this way. And 0x f0. Let's see how it goes. UF, nothing works. I will make it work. I will make it work. Just give me a while. Okay, 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 got it. This has to be the row, and this has to be the column. Now, now I think it should work, but there is still some error. Now the column should be this way. It should be arranged this way. Let's write P1 instead. Let's write P1. Okay, okay, okay. Something is better than nothing. Let me now turn on Proteus just to see how it goes. And got nothing. Nope, nothing at all. Nothing at all. Nothing at all. I think I have to change the program a bit. I'll have to change the program a bit, and for this I'll require a couple of minutes. Please wait, hold on. So I am back. Let me show you the program I have written. So, program is changed a bit. Let me tell you. So the first loop over here is for checking the rows sequentially, which I have already told you about. And here is the loop where we check the columns. So in the first, when we enter the first row and we turn off the first row, then we have to check for every column which column turns off, and according to that column, if it's turned off, then we after a a bit of delay, we check if it's still pressed, then we send the key, and we wait until it's unpressed. And the same sequence, when it's unpressed, then we search for the other button. If it's pressed, then um, we store it as well. So this is how it goes. It's a very simple program. Now it is, I have removed everything else. The bigger part is gone, so now it works fine. I just have to fine tune it a bit. Let me just see if I can do it over here. The So yeah, it works. I mean it works. So let's move towards the hardware. Probably we'll get to know something in the hardware now. um because it's already too late. Let me turn on the camera if I can. Yeah. So let me remove the IC. Place it in the burner and search for the burner. Let me just load up the file and see hex, which is current file. Okay, and now open error. What's an open error? Okay, yeah. So IC is actually not inserted the right way. I can remove this error. I can work this out. I don't think I think I should change the uh the port. There is this port left. Let me redo it, and now it works. So the port was the issue. Yeah, now it's already programmed. Let me remove the IC, place it here onto the board, and just remove the burner from the screen. And let me also include cool term. Oh, it's closed. Let's see. Let me include cool term. Oh, it's already there. It's already there. Great, great. What a great thing. Okay, let me just bring it down a bit like this. And first of all, let me configure everything up just to be sure. Turn off this thing. Okay, and connect. Okay, now the UART is connected, and I have to turn on my circuit. Hopefully I'll make it live. Yeah, so here we go. Moment of truth. Huh, nothing works. Strange. This issue with my USB as well. Still not working. That is very strange. Still not working. Let's arrange the IC. Oh man, I have connected the keypad in the wrong spot. It should be right here in port 1. That was the issue. It's still not working. Let's confirm it. Yeah, port 1 is the one. It's still not working. It's very strange. Still, it should work. There is no reason for it to not to work. Oh, now it works. Now it works. So the issue was that my board wasn't refreshed. Okay, now let's know the configuration. So one here is D and two here is hash. So let's replace it in the program, and let me just bring it down. One here is D. Okay, so one, two, three, and arrow. Um, what should I do with the arrow thing? Let's do this, and let's do this over here. 3, 6, 5, 4, 7, 8, 9, and this should be menu. I should write M, and this is enter. I should write E. This is cancel, so I should write C, 0, and silent, so I should write S over here. Let's see how it goes. Works flawlessly. Let me upload the program again. Let me burn the program again, once again. Yes, I see. Oh man, at last we are somewhere. I think it's done. Now let me turn on the camera. Turn on the camera. Is it the camera? No. Yeah, here we go. Let me place the IC back, which I have already programmed now. And let's see how it goes. So after placing the IC, while it's on, I have to reset the button, reset the controller. Let's see. Let me now increase the size of the screen and clear it up. So one, yeah, one goes over here. Let me so when I keep it pressed, now the debouncing thing is working. So nothing is, nothing is happening. And as many times as I press this, it's just going to recognize the whole thing as one single press. 1, 2, 3, arrow, arrow back, 6, 5, 4, 7, 8, 9, menu, enter, cancel, 0, and S. So here we go with all of the buttons and everything, and I'll include this program somewhere online, and I'll include the link in the description so it's easier for you to find. Now in this video I have already done the hardware section. I have covered all of the hardware things. I hope this has been useful for you. um, so if there is any question, I think if there is any question, you may let me know. Otherwise we'll have to end the stream over here. If there is any question, you should let me know. I don't think there is any question because all of the audience is silent. It's it's either because they're not understanding anything, or because they have gotten everything. So yeah, it's a good thing. Everybody's online and seeing this experiment perform live. Um, so this is how it works. Debouncing is the main thing which you have to consider into account. Let me just turn this camera off, and let me just explain the program a bit, and then we can end this stream once and for all. Let me just zoom it in. Yeah. So now I think it's better. Just to explain the program a bit. So this is how my keypad is arranged, and I found the layout after I uploaded the wrong layout. It's much easier for you to understand the layout once you upload everything. And don't worry, even I get this layout wrong, so there is nothing to worry about, unless if you have some enough time to just um, calculate everything and all the possibilities, so that way you won't be messed up. So moving on to the the okay, my laptop with battery is going down again. It's suddenly it's just after a couple of minutes it gets charged, and then it's not charging all of a sudden. So there is some issue with the charger. Let's get it done real quick. So to make the UART operational, you have to make use of T mode, which is the timer one, and mode two. I think the mode two is probably related to UART. That's why we have to uh, make it operational, and there is some calculation that you have to do before setting the baud rate. According to that calculation, when you place -3 in this TH1 register, it will constitute to a baud rate of 9600, exactly 9600, when you have a clock frequency of 11.095592. This thing I've already told you in the first lecture, where I've told you that selecting a clock of even 12 megahertz won't let you use the baud rate of 9600. There is some calculation issue that happens when you use a 12 megahertz crystal. This issue only has this issue only appears when you're using the UART. Otherwise, 12 megahertz crystal is just fine. It works perfectly fine with the other peripherals and other IOs. um, then comes the SCON register. The SCON is, I think, it's probably the status register, or whatever, the setup register, configuration register. You can look it up, the details of the this registers later on. TR1, once you place 1 in the TR1 register, it starts up the timer. And starting up the timer in 8051 means that you have start up the you have turned on the serial port as well, the UART port as well. So after this thing, whenever you press a push button, sorry, you press a button, it will send something on the serial monitor. And one more thing, you can easily now incorporate the previous LCD program into your current environment, into your current this program, where everything which you enter in the keypad will be um, uh, written on the LCD. So it's much easier for you now. Relatively, it's much easier for you now. Let me go through this program as well. So first of all, you have to scan all of the rows. You have to go through all of the rows, and then you have to make, just sequentially, you have to make one of the many rows just a zero. So once the row is a zero, then you have to search for the columns. If one of the columns is one, then you have to if one of the columns is one, you have to wait for a while. You can remove this wait if you don't want to wait for a while. but it's a good thing to wait for a couple of milliseconds. So the debouncing is, let me write it down, is 20 milliseconds. So over here you have to wait for about 20 milliseconds to it's just a debouncing. And then if it's still pressed, then you can, after 20 milliseconds, if it's still pressed, you know there could be a possibility that a noise happens or something else, some short circuit happens, and it seems like you are pressing something on the keyboard, but it's just the noise. So that's why a delay is necessary in this case. And 20 milliseconds is nothing. A 50 hertz cycle, the AC cycle is 50 hertz, and it has a time period of 20 milliseconds. So one cycle passes through the one whole cycle is of 20 milliseconds, so it's real fast. You don't have to worry about it. After waiting for a while, if it's still pressed, then you obviously, it is, by this instant it is decided that the key is pressed by a human and it's not an error. So after it is finalized, then we have to send it to the serial the UART pin. And after sending the data, you have to um, wait until it's released. And within this register, within this function, it is already there that if ti equals to 0, then obviously, um, oh, my laptop is running out of power, I have to make it real quick. There is a warning sign. So while ti is equal to 0, which is the transmit end. So I forgot it's the acronym. So it's something like transmit interrupt, or transmit end, something like that. Once it is equal to 0, then obviously we know that the transmission has happened. So yeah, this is the whole program which I've made so easy for you now. I'll be uploading this program somewhere, maybe on a Google Drive, and I'll be letting you know. So yeah, that's all for this stream. And if you have any question, you can let me know, but we don't have enough time, so I am going to end the stream over here. See you next time. Thank you.